Hello, sixth graders. Welcome to your video lesson on prime factorization. Make sure that you label the top of your notes with the title of the notes that you are doing, prime factorization. Our learning targets for today are that we can identify numbers as prime and composite. We can use prime factorization to determine factors of whole numbers, and that we can express a whole number as a product of prime factors with exponents. So some prior knowledge to activate and get ready to go. Just a quick review here of prime and composite numbers. Remembering that a prime number is a whole number greater than one that has exactly two factors, one in itself. A composite number is a whole number greater than one that has more than two factors. And remembering then that 0 and 1 are neither prime nor composite. So stop and think here, pause the video, and determine, writing down these numbers in your notes, if these numbers are prime, composite, or neither, and play the video back to check your work. Then you can pause again to check your answers. I wrote them as prime and composite, and I wrote the factors below. Check yours. Okay, so a little bit of a page with some information. Don't write everything down right now, but every composite number can be written as a product of prime numbers. So the product of those primes is called your prime factorization. So, for example, this here, these two pictures are called a factor tree. So this is a picture of a factor tree, and that is used to help us find our prime factorization. So, for example, 60, our composite number, can be factored or broken down into numbers until all that you have left are the primes that make it. So this is the prime factorization of 60. 2 times 2 times 3 times 5 gives you 60. Of course, there are other factors of 60 like 10 and 6, but these are the product of just the prime factors that make up 60. So here would be a good time for you to pause and have an example or write down these vocabulary words that we're going to be using throughout the unit to help you. Prime factorization, product of primes, factors, and factor tree. So we're going to try two methods to find the prime factorization of 24. You are going to find, again, the prime factorization. You are looking for the prime numbers that you can multiply together, factors, to make 24. So the first method is our factor tree. I want to make sure you write down both of these examples so that you have them in your notes to reference later. So if we have 24, to make a factor tree, you're going to think of any two factors that you know that make 24. It could be 2 and 12, 3 and 8, 4 and 6. It's really up to you, any two factors. So I'm going to go with 4 and 6. Neither of those are prime, so I know that they can be reduced even more into factors that are prime. So numbers that make 4 are 2 and 2, and those are both prime, so I'm going to circle those because that is as far down as it can go. And then for 6, factors are 2 and 3. And I can't keep going with those because then I'm getting 2 and 1. And remember, 1 is neither prime nor composite. So I stop right here at 2 and 3. And I write that as a product of primes for prime factorization, 2 times 2 times 2 times 3. I'm going to try to avoid using those x's for multiplication. Another way to write this, if I have 3 2's multiplied by themselves, that's 2 to the third power times 3. Second method is our divide by primes. So instead of picking any factors, you are going to do upside down division, but you're going to pick by the smallest prime you can. So the smallest prime is 2, and that's divisible. 24 is divisible by that. So I get a remainder of 12. 12 is divisible by 2. You get a remainder of 6. 6 is still divisible by 2. Remainder of 3. A lot of times we want to stop here, but 3 is divisible by 3. So we want to end when we have 1, and we can't divide that anymore by primes. You'll notice we have the same thing here. We have our same result of 2 times 2 times 2 times 3, or 2 cubed times 3. And double checking it, if you multiply those back together, you will get 24. So now you try. This is a great place for you to pause. Try both methods in your notes. to find the prime factorization of 18, both the factor tree and divide by primes. So you can kind of get a hang of both and then come back and check. Okay, so you're coming back to check. So we have 18, and I might choose different factors than you did. I'm going to choose 2 and 9. I ask, are any of these prime? 2 is. 9 is not. 9 has factors of 3 and 3, which are both prime. So my prime factorization, least to greatest, is 2 times 3 times 3, or 2 times 3 squared. And again, checking those, if you wanted to work back, checking that it gets back to 18. Division by prime, so I start with 18. I like to start with the smallest prime I can, which is 2. And then the smallest prime I can divide 9 by is 3. And again, I like to make sure and get all the way down to only 1, so then I can see that my prime factorization of 18 is 2 times 3, or 2 times 3 squared. So noticing both methods gets me to the same place. How'd you do? Okay, so you decide here if you want to try one method or both methods. If you want to try them first, then pause and come back and check. Or if you want to go along with me for one and try one on your own. So starting with 285, I know that it ending in a 5, that it's going to be divisible by 5. So I'm going to start there. I might have to do some side work and do 285 divided by 5 to figure out that the other factor is 57. 5 is prime. What I know is that 57 is close to 60 and it's 3 away, and that 3 is a factor of 60. So 3 also must be a factor of 59. And if it's 1 less 3, then that would be 19. Both of those being prime, then I can write my prime factorization, which is the same as product of primes. Product meaning I'm writing out my primes multiplied together, least to greatest order. For 160, see if you're going to pause and give that one a try. So again, you get to decide what method are you going to do. Just to give you some variety, I'm going to do division by primes. Ends in a 0, so I know it's divisible by 2. I know 16 divided by 2 is 8, so I know this is 80. Also divisible by 2 for 40. Also divisible by 2 for 20. Still divisible by 2 for 10. And one more divisible by 2 for 5. And then 5 is another prime divisible by itself, left with 1. So then I can see that I have 2 times 2 times 2 times 2 times 2 times 5, or I can write that as 1, 2, 3, 4, 5. 2 to the 5th power times 5 is the product of primes, or prime factorization, of 160. So prime factorization with algebra isn't really any different. We're treating our variables as a number that we don't know yet, so we're treating them as their own number, possibly could be prime. So what you do here is you take 18 and you just factor that, 18 times C times D. So it's kind of like this is 18 times C times D. C and D, we don't know what they are, so they're already done. Those are done and they're prime. We're going to consider 18, then we have to keep going for 2 and 9. 2 is prime. 9 has factors of 3 and 3. So what I did is I factored the entire number considering C and D as their own prime numbers. So then I have 2 times 3 squared times C times D would be the prime factorization. That's the same as 18CD. For 50x squared y squared, similar, I'm going to split up my variables and my number. So I know that this has 3 factors. We have 50, x squared, and y squared. What you might remember about square numbers is that it's a number times itself. So I can actually factor these out to be y times y. Now I can't factor that any further, so I'm done. X squared is x times x, so now I can't factor that anymore. So for 50, I know it's 2 and 25. 2 is prime. 25 is 5 times 5, both of those being prime. So the prime factorization, or the product of primes, of 50x squared y squared would be 2 times 5 squared, again, backing up to x squared times y squared. So you're really bringing those variables back to as they were. So now this slide, we are just doing the opposite. We're working backwards. If we know the number and we know some of the prime factors, we have to find the missing one. So we're looking for this missing one here. So what you're going to do is just work forward and backwards. So what I'm going to do is say 2 squared, I know is 4. Then this is 4 times what? You could put a variable there. Times 3 would give me 1,500. So I can change this out of order. I can do my 3 times my 4 because of commutative property. So I know that 12 times something is supposed to give me 1,500. Well, if 12 times something gives me 1,500, then I can divide 1,500 divided by 12 to figure out what that missing factor is. And it's 125. But I'm looking for the prime numbers. So I know that the missing part is supposed to be 125, but I have to write it as primes. So I'm going to factor that out. I know it ends in a 5, so it's divisible by 5. So I find out that 125 has a prime factorization of 5 cubed. So that's my remaining part. So I know that 2 squared times 5 cubed times 3 is equal to 1,500. And it should be ordered least to greatest, but instead of filling in the blank, I'm going to leave it just like that. So one more, maybe you want to give it a try and then come back and check. Pause if you are going to. So what I know is I'm looking for the missing part. 3 times 2 to the 4th times what gives me 1,200. So I'm going to work forward a little bit. 3 times 2 to the 4th power, which is 16, times another number should give me 1,200. So then I keep going, multiplication. I have 48 times that certain number. I have a blank. Again, you could use a variable, advancing to algebra there. So this means that I have to figure out what times 48 gives me 1,200. So I know 1,200 divided by 48 is 25. So that should be my missing part, but I need that in primes, and that are 2 5s. So my missing value is 5 squared. And again, checking that and working forward to help you know. Here are some if you'd like to try in your notebook to bring them to class to know if you are ready. Look back over your notes, check for understanding by explaining these concepts to somebody else, rewatching any section of the video that you need to, trying more practice problems. Don't forget to have your notes with you in class tomorrow. Have a great day.